Hi there, it's Mr. Rops, and we are factoring quadratics when a is not 1. And this is the a value, which is in front of our x squared, and it's not 1. Whenever that's not 1, the first thing we always look out for, common factors. Look for that first. It will simplify your life if you can get them. So let's take a look at this first example here. We have 3x squared plus 15x minus 72. And if we look carefully, I can see that 3 is a common factor to each of them. 3, x squared plus 5x, because I pulled the 3 out of here. If I pull 3 out of 72, I get 24. That's a bit tricky of a factor to get, but it is inside there. And now we have to factor this second part here. We want to factor x squared plus 5x is minus 24. Well, I multiply x squared and 24, so negative 24x squared. I get 5x. What multiplies to get negative 24x squared and adds to get 5? Well, that's going to be an 8x and a negative 3x. Putting it into my box, I have x squared minus 24. And I have an 8x and a minus 3x. Pulling out my factors now. This part is similar to what we did in the last class, so I'm going to go through it fairly quickly. I pull out a common factor of x, pull out a common factor of 8, go in this direction, pull out a factor of x, and I pull out negative 3 because this is a negative value. And so I have 3. And I have x minus 3, and I have x plus 8 are my 3 factors. Fully factored, this one had the common factor that you have to look out for. Let's try another example. So, we look at these terms here, and lo and behold, I get 60x, 10x squared, and negative 10x cubed. They all have a factor of 10x. So if I pull up 10x from here, I have 6 plus x minus x squared. Now, when I'm factoring, the way this is written right now is not very helpful to me. I want it to be a positive x squared in front. I need to make this positive. So what I can do is I can pull out a negative sign, and so it's equal to negative 10x, which makes this positive, makes this one negative, and positive 6 will become negative 6. And I can write it in this order. Now it looks familiar to me. This coefficient in front of x squared is 1, so I can make my box. I multiply x squared and 6. I get negative 6x squared and negative x. I'm looking for multiplying to get negative 6. Adding to negative 1, well, that's negative 3x and 2x. Making our box, I know I get x squared from here, negative 6x, and then negative 3x and a 2x. Factor, I get x minus 3x and 2. And so, putting it all together, I take my first factor, negative 10x, times x minus 3, times x plus 2. And this is fully factored. So, common factor first. Then I recognize I have to put out a negative sign, so I write it in this order. I want it to be a plain x squared if I can, and then the x, and then what we call the constant at the end. Another example, we look for common factors of 5. Well, 14 and 3 is not going to work. So now there's no common factors. We have several approaches we can use. The first one I can do is I'm going to do it graphically. No, I'll do it algebraically first, then we'll go to the graph. So here we go. If we look at this, I know I'm going to multiply these two together, And so when I multiply those, I get negative 15x squared. I get the 14x. And so now what multiplies to get negative 15 adds to get 14? Well, how about 15x and negative 1x? Make my box, and I get 5x squared, which comes from here. Negative 3 goes here. And then I take my 15x and my negative x, and I start to factor. Here I have a common factor of 5x. Here I have a factor of x. Here I have a factor of 3. Go in this direction, I have a factor of 5x from 5x squared and 15x. And here I have a factor of negative 1. And so this factors to 5x minus 1 and x plus 3. That's our factor. And I could check by multiplying. If I multiply this out, I get 5x squared, I get a negative x. When I go the box here, I get this. 5x and 3 is 15x. 3 and negative 1 is negative 3. And they all add up to this. Now that's algebraically. How can we do it now graphically, using our calculators to help us out? So look at my graph. I'll do a quick sketch here. And I know I have something that looks like this. I have something that looks like that. There's an x-intercept here and here. Let's find this one first. And if I look at my calculator, I'm going to guess it's 1 to negative 3. And if I trace on it and go negative 3, I hope y is 0. Indeed, that's true. So I know this is negative 3. This one, however, is not 1 and it's not 0. It's some kind of number between 1 and 0. So I'm going to calculate it by finding the 0. The left bound of this number I'm going to say is negative 1. My right bound of that number I'll say is 2. And I'll guess it to be 0 even though I know it's a little bit bigger than 0. I get I get x is equal, this value here is 0.2. X equals 0.2. Now, I know then that this becomes x plus 3 and x minus 0.2. My problem is if I multiply it as is, I don't get this. One of the rules of factoring says that all these numbers that are in here, they must be integers. Okay, so if I take this and think about my fraction, I know this is x plus 3, and this is x minus 1/5. I know that this is what I want to get. And if I rewrite this equation, I want to get a 5x squared in the beginning. When I multiply, I'm going to multiply this side by 5. Just the second term by 5 to get rid of my fraction. And I'm not saying that these are exactly the same graphs, but I am saying they both have the same factors. Because what the graphs we're looking for, and this might be a little bit tricky to understand, is this graph goes through the same two x-intercepts. This graph goes through the same two x-intercepts. And the pictures of these two graphs are slightly different because they could have different bend to the graph. But it's the x-intercepts that are key. And if I change these all to numerical values, or integer values rather, I will end up with my initial thing. Okay, so two methods. One is algebra. The second is by using our x-intercepts, but then converting all these numbers to integers by multiplying. Okay, we'll try this one now, and let's do it graphically squiggly. So I'll clear that and we'll go 6x squared minus 5x minus 6. We'll graph it. And we can see that we have this graph here, which looks something like this. This one here, I'm going to guess that's 1.5, but let's find out. And I'm going to find the 0. If that's 1.5, my left bound is going to make it 1. My right bound, I'll make it 2. And I'll guess 1.5. And indeed, that is correct. So this is 1.5. If I think about fractions, that's the same as 3 over 2. It's minus 3 over 2. I don't want any fractions in here, so I'm going to multiply by 2, and I get 2x minus 3 when I multiply this by 2 and this by 2. Working on the other side, I'm looking now for this x-intercept, which is between 0 and negative 1. So I'm going to find the 0. My left bound I'll make negative 2. My right bound I'll make 0. And I'll guess at negative 1, even though I know it's smaller. And I get negative 0.66666666, which I know that is negative 2/3. And so this factor is x plus, remember I changed the sign, 2/3. Change it to integers by multiplying by 3, and I get 3x plus 2. And so here are my factors, and that's graphically. If I want to do it algebraically, and I'm going to have to be able to do it both ways, to do it, let me clone this page. We'll try it again. And I'll erase my ink. So, algebraically, make my cross, multiply them, I get negative 36x squared, negative 5x, multiplies, I get negative 36, adds, I get negative 5, that's a negative 9x and a positive 4x. Converting to my box and going backwards, I get 6x squared and minus 6, a negative 9x and a 4x. Starting to factor, here I can pull out a 3x. Here I can pull out a 2. From these two I can pull out a 2x. From here I can pull out a negative 3. And so it factors to 3x plus 2 and 2x minus 3. This is my factor. If I look back here, it is the same as this one. It is also equally correct to write it in this order. The order doesn't matter. Because this is multiplying, you can switch them around. Another one here. I'm going to do this one algebraically. Multiply negative 12x squared and negative x. Now I'm going to stop here. You should pause the video, try it yourself, see if you can get it. That's right, pause it. Pause it. Okay, now you're back. So multiplying to get negative 12, adding to get negative 1, negative 4x and 3x. So if I make my box, there was no common factor, I get 4x squared, negative 3, negative 4x, and a 3x. Here, the only thing I can pull out here that's common is a negative 1. Here is an x. Here I can pull out a 4x, and here I can pull out a 3. And so my factors are 4x plus 3, and this is x minus 1. Hopefully you got the same thing. This one. Make sure you pause the video, try it yourself. Try it. Don't pause. Okay, step number 1. Now that you're back, I'm going to pull out a common factor of 2. So it's 2x squared plus 13x plus 6. I could do this with my calculator, look for the x-intercepts, or I could do it algebraically. Dealing with the inside part, multiply, I get 12x squared, and it adds to 13x. So now I look to multiply to get 12, add to get 13. Well, that's going to be a 12x and a 1x. Moving to my box and putting the area of 2x squared in. And 6 and 12x and x. Common factors, and I get 6. I get x, 2x, and 1. And so 2x plus 1, and x plus 6. This is the fully factored. I have to get the common factor out. And finally, try this one on your own. We'll check it in class to see if you're right. Use either technique, but you could do it algebraically and check it graphically, or do it graphically and check it algebraically. Good luck.